percent problems using the percent of increases and decreases. For examples, markups, markdowns, tax, discount, and so on. All right, here's the ideas you need to know for this video. Markups and tax, they increase the cost. Markdowns and discount, they decrease the cost. The key idea we're going to use is that the original cost is 100% of itself. So if you have the idea of a markup or a tax, you can take 100%, which is the original, add it by the percent of markup or tax, because again, markups and tax increase the price, and that will give you the percent that you as the customer end up paying. However, if it's a markdown or discount, then that's a percent of decrease. So you would take 100% for the original, subtract by the percent of markdown or discount, and that will give you the percent that you pay, often called a sale. Now, we're going to use the idea of the percent equation, and we're going to modify it a little bit. Instead of part and instead of whole or base, we can use the words final cost and original cost. Here's what I mean. For markups and tax, again, you add 100% by the percent of markup or tax to get the percent you pay. You will put that in decimal form, and you will take that times the original cost, and it will equal the final cost. If it's a markdown or discount, again, 100% minus the percent of markdown or discount. That gives you the percent you pay. Put that in decimal form times the original cost. It will equal the final cost. Let's look at some examples. Janice bought headphones for $49.95 in a state that charges 6% sales tax. Maybe that's Pennsylvania. Find the final price. All right, let's use the idea we've been talking about. Sales tax will increase the price. So we're going to take 100%, representing the original cost is 100% of itself, add it by the sales tax. That means you will pay 106% of the original cost. Put that in decimal form, 1.06. Take it times the original cost of the headphones, and it will give you the unknown final price. You can call that whatever variable you want. I'm going to use capital P for that. Since that variable is by itself, we don't need to divide or use any kind of inverse operations. We will just use our calculator. Now, this will give you 52.947 dollars and cents. Always 2 digits after the decimal point. So look at the third digit to round the second digit. That's why it's 95 cents, because the 7 rounds up the 4. Next example, on a clearance sale, sweaters that normally sell for $35 are 75% off. Find the sale price. Now, since it's 75% off, it is coming off. It is taken away. This is a decrease. So 100% for the original minus the 75% off means you only pay 25% of the original cost. Put that in decimal form, multiply it times the original cost that the sweaters normally sell for, and that will equal the unknown final price. Now, I know this problem didn't say final price. It said sale price, but sale price means the final price after the sale has been applied. So go ahead, use your calculator. This will give you $8.75. One more example. It costs $25 to make a skateboard. Find the selling price after a 230% markup. Now, the idea of markup is an increase. It costs a certain amount of money to make an item, but to make a profit, you have to mark up the price. So that is what's happening here. Now, that doesn't mean that you pay 230%. No. The original cost is 100% of itself. Add it by the percent of markup, you end up paying 330% of what it cost to make that skateboard. So put the 330% in decimal form. Since we are finding the selling price, that's the unknown final price. So we're going to take 3.30 times the original cost of making that skateboard, and that'll give us $82.50. Now, we can use the ideas of markups and tax for any percent of increase problem. And we can use the ideas of markdowns and discount for any percent of decrease problem. Here's an example. Tasha made $12 per hour last year at her job. She gets a 25% raise this year. If she gets a 25% raise this year, what will be her new pay rate? The key word is that it is a raise. That is an increase problem. So we can take 100% plus the percent of increase, and it will give us the percent that the new pay rate is from what it used to be. And then we can kind of use the same formula we used before, except instead of talking about prices, we are talking about pay rates. We got a new pay rate equal to the percent of decimal form times the old pay rate. So let's go ahead and do that. 25% raise. She's now going to make 125% of what she used to make. Again, a raise is an increase. That's why we added to 100%. Put that percent in decimal form. Take it times the old pay rate of $12 per hour. That's going to equal the unknown new pay rate. And you can pick any variable you want over there. Use your calculator. She is now going to make $15 per hour. One more example. This year's population is 5% less than what it was last year. If last year's population was 4,980 people, what is the population this year? Keywords, it's 5% less than. So this is a percent of decrease, which is why we're going to take 100% and we're going to subtract by the percent of decrease to get the percent that the new population is from what it used to be. And then again, using the idea that the new is equal to the percent of decimal form times the old. Let's go ahead and do that. 100% subtract 5%. It's now 5% less than. That's a decrease. Means the new population is now only 95% of what it used to be. Put that in decimal form. Now, take it times the old. Last year's population is the old population. We're going to multiply that times 0.95. That will be equal to the new. Again, I picked P for population, but you can pick any letter you want. Multiply this in your calculator, and you will get 4,731 people.